Dodson. Estelle and her team have been supporting virtual conferences and collaborative science here at NASA Ames and across the agency for a number of years now, and it's largely due to their team, that team, that we have done so well with our virtual technologies in this conference. So we really appreciate you talking to us, Estelle, today.
Thanks.
Thank you.
And so as Jennifer mentioned, there's a group of us kind of behind the scenes that run a lot of these technologies and have learned many things over the years of best practices, lessons learned. So I'll try to share some of that with you today, and then the structure of our Astrobiology Institute, which is a virtual institute, and we've now started a few more. Last year, I guess, as a result of a review that we had from the National Academies at our 10-year birthday, I guess you might call it, we brought in a social scientist, Arsev, and Arsev will speak to you a little bit about collaboration, changing from traditional research to a more virtual environment, and then at the end he'll talk about Data One, which was a project that he worked on as part of his dissertation, and he specializes in interdisciplinary collaboration, among other things. So that's just a little bit of overview of our background. And Mike, how am I doing? Louder?
Great.
Okay. Okay, so I'll give an introduction. Arsev will talk about what is collaboration, and then I'll talk about I'm going to talk about the astrobiology collaboration infrastructure, but that's what a lot of the other groups that are starting to form are following. So because we have the now 14 years of experience with astrobiology and a lot of things already in process, that's what I'll focus on, and then Arsev will finish up with Data One. So as I mentioned, the Astrobiology Institute, it's an interdisciplinary virtual institute, meaning we're distributed around the country. We started in 1998, and then in 2008, the NASA Lunar Science Institute was established. And then just this year, we've been launching the NASA Aeronautics Research Institute, and that's really to look at innovative design and technologies in aeronautics and a focus on green type aviation issues. So Workshop Without Walls, we're distributed, we have 14 teams that are competitively selected, and we're all over the country. When you add up all the team members, we have about 850 people across 150 institutions. So what we try to do is bring them together to collaborate and share information, both across distances, but across disciplines is one of the larger challenges. We're a headquarters level program managed at Ames. I don't know how much that means to this group here, but it can make a difference when you're talking about organizational issues and who reports to whom, that type of thing. We also have international partners, and international partners, those agreements have to happen at a governmental level. So there's a lot of overviews and document signing to make that official so that we can actually exchange resources, people. There's not a money exchange, but there's a sort of a commitment to working together. Astrobiology specifically looks at how does life evolve, how did life originate, how does it evolve, does it exist elsewhere in the universe, what are biomarkers, if you're looking at other planets for signs of life, what would you look for, what is the future of life on Earth and beyond. So our mission statement starts out with doing collaborative interdisciplinary research, training the next generation of astrobiologists, providing leadership for NASA space missions. NASA really operates around missions. That's oftentimes the driver. So working with the missions is very important. Education outreach is a big priority to NASA and STEM education, and then innovative information technology for research. In addition to the NASA astrobiology research, there's a couple other programs funded at headquarters in technology development, so those sort of work together. But the one thing that you see, what do you see in common in all of these pictures? Yeah, it's people. So we're really dependent on people, the relationships between people. Research doesn't just happen on its own. Data doesn't just happen on its own. So it's bringing together the people in a way that works effectively and allows you to have insights and discovery. So we approach people issues, and then everything comes in around that. So astrobiology, just as you get a sense of the questions that we're looking at, it's highly interdisciplinary. So we have people who are astronomers, geologists, physicists, chemists, biologists. We even have philosophers, because if we were to discover life on another planet or figure out how life originated, there's some pretty high-impact philosophical questions that come about. And for that reason, having an interdisciplinary collaborative institute that you can pull from experts all over the country without having to bring them into one spot is a pretty powerful model. And so now, bringing into to define scientific collaboration, which is Arsev's area of expertise, I will turn it over to Arsev.
Well, let me give you the definition first, and I hate definitions. But I will tell why I hate, and they can mislead us. Scientific collaboration is the family of purposeful working relationships between two or more people, groups, or organizations in order to research phenomena, to develop a scientific instrument or technology, to build a facility, and to publish a study. So everything is a collaboration almost in the scientific realm. That's not wrong, but some of the stuff could be considered as collaboration if a flash mob is a collaboration, for instance. A flash mob coming, for instance, we had this meteor coming down just last month or 2 months ago, and NASA organized, I wouldn't say a flash mob, it's too strong, but we received an email one day, if you want to help us collect the pieces of this meteorite, just get on the bus, we're taking buses to this region, and you will be looking for little tiny stones and all over the mountains, valleys, and stuff. So it's not a flash mob, but it's a collaboration. But it's not a team. I focus more on teams in my research, but a lot of things could be a collaboration. Human Genome Project is a collaboration. Many countries, United States, UK, Japan, Germany, France, Spain, they all collaborated on that. Or developing for instance, the Keck Observatory Telescope. Caltech and other institutions came together to do that. Publishing a study, yeah, you all know that, so it's not a big deal. So who comes together? That's the thing with definitions. Let me go back, yeah. A purposeful working relationship between things. With this definition, Fellowship of the Ring is actually a scientific collaboration. You have these people come to, even not human. You have elves and hobbits and dwarves and other creatures. They come together to research a phenomenon. Can we destroy this ring? We have a research question. It's quite scientific for its age. You need to develop an instrument to get rid of that ring because the guy tries with the axe. And you need something special, so you need to build a technology to destroy that ring. You need to build a facility. They want to stop these attacks at Minas Tirith, so they have this huge castle. You need to have see, with this definition, and you need to publish a study. That's the book. Frodo writes before Bilbo Baggins wrote the book. So it's a scientific collaboration with these definitions. So I do not, stick to the definitions. I will make a lot of definitions during my presentation. And at the end, I will say that, it's not very right to stick with this definition. It's like, teaching physics. You always tell students to neglect friction, but it's always there. And in order to be a researcher, you have to always consider friction. So it's like that. I will make the definition and I will say, yeah, don't take it, don't buy it. It's fun to be a social scientist. So individuals could come together, Dr. Jekyll and Mr. Hyde. They can come together. Or research groups could come together. For instance, Georgia Tech and Montana State University Astrobiology, they both focus on the origins of life, and they come together and work on that problem. Organizations could come together, like for Data One project, University of New Mexico. I will mention this one in detail. Oak Ridge National Laboratories and NCs could come together. Or International Space Station. Many nations could come. Although at the beginning it was Space Station Freedom, it was the aim of that project to show the Red Russia the power of mighty America. However, because of the deficits, they needed international partners, so they changed the rhetoric, and space station freedom has become international space station still. The orbit functioning pretty well. So why do we collaborate? Well, because we can't do it alone, especially now today. The questions are so complex. Climate change, and Einstein cannot come, reincarnate, and solve that problem. Because it needs a lot of expertise. Even though let's assume you have all these expertise, you do not have enough time because there's a lot of things to do. You have to collect data, you have to analyze it, you have to interpret it, you have to integrate it from different disciplines. So a division of labor is needed. Resources are needed. Also, sometimes just because of credibility, you collaborate with someone. I am at the bottom of the food chain. I'm a newly minted PhD. It's been almost a year. It's been a year. So if I want to publish something, for me it's important to find a nice partner, famous partner, so that I could get some credibility through him or her. So that's the reason, just to share expertise, share credibility, share resources, social capital, symbolic capital. These are the buzzwords in social sciences, but not everybody knows their meaning. It's not very important. Since then we collaborate. Generally, the Manhattan Project is the thing. After that, big science came into play, and governments decided to fund basic research. Where? Well, I said localized until digital revolution, but even the Manhattan Project took place in 50 different sites all over 3 countries, with 5,000 people working on it. But now it's almost, now we don't have these boundaries. Thanks to computers and internet, everybody is everywhere doing everything. It is a hell to conduct the research on that because I don't know who is where doing what. It's impossible to track. That's the hell of a social scientist. So what do we look for? We look for their productivity, decision making. For productivity, we look for the articles they publish or the patents they get or the outreach activities they do. It could be anything, not only scholarly productivity. And another important thing about productivity or the success of a collaboration is, are they over the budget or not? And that's the huge concern. And all other things are here, very important. Trust is the main thing. You do not collaborate with people you don't know. And that is a big problem in virtual research organizations because you need to know this person, at least meet once face to face in order to trust, most of the time. So all these issues I study. It gets really messy. Well, sometimes people, if it's really good, why not everybody is collaborating? The original slide says because people are greedy and stupid. Thanks to Estelle, it's more politically correct now. People are self-motivated and short-sighted. There is a lot of competition happening. I'm not American, and in my culture you talk directly when you say things.
I filtered and gave it to you.
Thanks to Estelle, it's more polite now. And technology literacy is a concern, especially for senior scientists. They sometimes don't know how to use Adobe Connect. They might use Skype, but they don't know how to use, for instance, Adobe Connect. And they are kind of avoiding that kind of technologies. But, in 10, 20 years, they will all rest in peace. So you will carry the flag and you are technology literate. Things change that way most of the time. Let me tell you before I hand over to Estelle the difference between traditional and virtual research organizations. Traditional organizations are localized. Has to be, otherwise you have to pay a lot of travel money. Unfortunately, the problems are so big nowadays, you do not have that resources in one place. If you're dealing with climate change, there isn't one city that you can have all the experts living there for 20 years to find a solution to that problem. So it has to be distributed. Virtual research collaborations generally form bottom-up. You find someone, he finds someone else, then three of you heard from other people in Toronto working on the same problem, you contact them. It's a bottom-up formation. So it is, the structure is more fluid, more adaptive, less stable. That could be a problem sometimes. And they, of course, use information and communication technologies heavily in order to communicate in distributed networks. And we will come to that in my examples in the second half. And yeah, let me hand it to you.
Okay. So how do you collaborate virtually? That was the question that we faced years ago. And what we've found to work effectively is this sort of collaboration infrastructure. So originally we started from a technical point of view. Give them one big tool and everything will work magically and people will start to interact and share and communicate. And we found pretty quickly roll out one gigantic enterprise solution and everyone stays in their silos and no one communicates or collaborates. So then we took a step back and we started looking at the big picture and looking at the organizational relationships and the social relationships and the technical and even how people interact with the technology. That's an important component. So when you bring together the organizational infrastructure, the social infrastructure, and the technical infrastructure, then you have something in place where people can begin to collaborate. So when they do meet face-to-face, as Arsev said, and I'll touch on that in a moment, you have the infrastructure in place that they can continue those relationships and continue to interact. So first I'll just talk a bit about the organizational infrastructure and how we're set up. A lot of other government agencies follow similar organizations. Some are different just depending on their operating rules. But we're funded, the 14 teams are funded through what's called a cooperative agreement notice. It's similar, it's similar to a grant, but a grant, the way we think of it is, here's the funding organization, you give the money to the PI, and then a year later they report back. And it's a very sort of one-to-one interaction. What we try to build out here is a synergistic network where the sum is greater than the parts, and all the members can communicate with each other without our organization being a bottleneck. Now, there are times when centralization makes sense, like hosting a website or sharing data sets, things like that. There's times that centralization is good, but then you don't want to limit the interaction with all the nodes. So we try to have this sort of balance between the two. Do centralization when it makes sense, but then allow people to do what they need to do, give them the autonomy to innovate, to communicate, and collaborate. In the beginning, we were set up with five-year CAN cycles, and this was due to, I think, the insight from some senior scientists that had a lot of experience with funding cycles and the challenges to short funding cycles, especially if you have a short funding cycle when you're trying to build a community. That's pretty challenging for long-term continuity and sustainability. So the folks that came up with this idea in the first place of this virtual institute said 5-year cycles, and then furthermore stagger the funding cycles. So once the first teams came on, a couple years later we started the second funding cycle, meaning there was overlap. And then where that became very important was in the third cycle. So we had a bunch of teams leaving. We'd gathered all this knowledge and expertise and relationships, and we didn't want them to just leave and disappear. So there was this, the second set of teams come in, they start to build a community, and then the third set came in after the first set dropped off. But there was actually a lot of interchange between the first set and the second and the third. So you start to see connections where PIs become co-Is, co-Is become PIs. And so you never have a situation where the entire community is leaving at once to be replaced by an entirely new community. So you get that corporate knowledge or that cultural knowledge that carries through. And the teams actually train the new teams quite a bit just from modeling behavior and watching each other. So as I mentioned, there's currently 14 teams. You can see the little icons down here. The teams tend to focus on a more focused research area, and it's somewhat interdisciplinary, but they're really working together to address a specific thing that's their area of research. To help, I guess, in the ways in which we see people working outside of the teams are through other programs, and I think that helps to strengthen the fabric of the community of the Virtual Institute. The teams themselves are distributed. Usually they're more in one location, but they do have people that they work with in other locations. But when you get into these other programs, that's where you get more interdisciplinarity and more cross-team collaborations. I'm not going to go into all of these, but I've highlighted a couple things where I think we see a lot more cross-team interaction and interdisciplinarity. Also building, sort of training the next generation and strengthening the fabric. The focus groups come together. We have 10 focus groups, and they're usually looking at sort of a broader question. How did life originate? That's fairly interdisciplinary. As opposed to like our team at Georgia Tech, they're looking at the structure of the ribosome. When you take it from the structure of the ribosome to how did life originate, you're going to get more people, more insights, more expertise contributing, and then you also get a lot more interconnectivity. So those are the focus groups. They get a small amount of funding every year, and there's usually 1 or 2 leads that keep it going. The postdoctoral fellowship program, to me, from what I've seen over the 10 years, that's a really important area for collaboration, because the postdocs, the grad students, they're very connected. They reach out to faculty, they reach out to each other. They're often going from one university to the next and carrying those relationships with them. So that's been a phenomenal way to build the community. Now, after 14 years, we have some folks that started out as graduate students became postdocs, and they're now PIs. So to me, that's a really rewarding thing to see them go through that whole process, and you start to feel like you're part of a real community or a family. And then astrobiology summer and winter schools. That's during summer and winter, there's universities that host schools that give training in astrobiology. They often do field work, but again, they come together face to face. They interact. I think there's something about doing field work that you really bond with each other. And then when you go back to your home institutions, you can continue those relationships. And I've seen a lot of relationships between one person, 2 people that were at a school together, went back to their home institutions, and then their friends started interacting with the people they'd met and things like that. So that's important. And then AbGradCon is something that's put on by the graduate students for graduate students, and it's a way, and no senior scientists are allowed. So they took the initiative to get this started. It's hosted at one of our research team sites every year, and it's an opportunity for them to interact with each other without sort of the pressure of giving a talk when your advisor is there, or really being able to give each other feedback and build those relationships. We have a lot of other things that go on as well. Workshops, education outreach, field work. But those are the ones that I wanted to highlight because I think they help to build the community. So the social infrastructure. You hear a lot about collaboration lately, and about a year ago there was an article in the Harvard Business Review about collaborative leadership. Well, there's a whole volume about collaboration, but one of the articles is about collaborative leadership. And I think a lot of us that have worked in the institutes have realized the importance of leadership when you're building collaborations. So this article, I thought, highlighted some things that were in line with what we've seen. The collaborative leader, and this is something to think about as you go into your career. How can you be a collaborative leader and work in collaborative organizations? But they attend conferences outside of their specialties. They make global connections. Their team members are from diverse fields, so they're good at reaching out and recruiting people from areas outside of their traditional discipline. They collaborate at the top and they model behavior, so that sends a message to their teams and the people they're working with that this is a good thing to do. Decisive with clear authority. That can be a challenge, I think, especially in science when you're often sort of matrixed. It's not like someone is reporting to you, and but they are still decisive and set a direction. And then for the collaborative organizations, it's very similar, but defining and building a shared purpose is a really powerful approach. You can have lots of great people, lots of great ideas, but if you're not marching together, you just get a bunch of random motion. But being able to bring people and together, sharing the same ideas, building consensus, that's when you get all that energy going, towards one shared goal. Ethic of contribution. Collaborative organizations that do well tend to reward people working with others, sharing ideas, so building that culture is helpful. Scalable processes for coordinating efforts. I think this means consistency in how you get things done. If things are often changing, and that can be a challenge at NASA, from one center to the next, there's different paperwork, different processes. But if you're not constantly reinventing the wheel, that helps the organization be more effective, because they're not always trying to figure out, how do you do this week? How do you do it next week? Similar to the ethics of contribution is infrastructure that rewards efforts. And then collaborative problem solving. When you bring a team together to say, how are we going to do this? People feel ownership. They feel like they have something to contribute. So really bringing folks together to work together, it increases that feeling of connectivity and trust. Look to community members to fill important roles. When we're doing any project, a lot of times we say, okay, well, who's going to be a good leader on this? Who's a connector? Who's a communicator? What influencers do we need around NASA or this university to make sure that we have administrative buy-in? But really, when you're starting something new, or when you're even continuing or trying to get things done, people in your communities have different personality types, different roles, and understanding what they're good at and what needs to be done, and tapping into those resources. Not just this is a skilled person at modeling, but here's a great modeler that has connections in this community, that has influences here, or here's a person that is a real natural leader. So understanding what people are good at and bringing that together as sort of the cohesive whole to move things forward it can be powerful. I think we unconsciously tap into a lot of influencers because we are matrixed. Knowing who influences the communities that you want to get engaged is a good thing to be aware of. And then building the community. Just a quick story here. When we it was at the CAN Cycle 4, we had, for funding reasons, we had 4 new teams that had started maybe a year prior, and then we had 10 new teams coming on. So effectively, we had almost 14 teams that were just starting to get traction. And we thought, well, how do we get them to collaborate and learn a little bit about each other's research? So we started with 15-minute presentations by the PIs. So a couple times a year, we do have a face-to-face meeting with the PIs. So all the PIs were there, and each of them gave a 15-minute presentation about their work. Everyone went back to their home institutions, and then we did a series of virtual lectures similar to using a lot of the technologies that you see here. But we gave 14 one-hour virtual team seminars where each team would present, and we tried to make it so that it wasn't the PI presenting. We really wanted to give voice to the co-Is, to the postdocs. So typically the way they used that hour was 6 people presented for 10 minutes each, and the whole community came out and watched. So it was sort of a mini-to-mini exposure to the various areas of research that was being done. And we tell people, start broadly, talk about how this is relevant to astrobiology, and then in the last part you can go more into the detail of your research. But that's another challenge of interdisciplinary communications, is making it relevant to the larger group, but then still being able to address the more focused area of your discipline. So we did those virtually, and then we had an in-person meeting where we had about 100 people from the teams. Each PI invited 2 to 5 of their researchers. We did a face-to-face where we came up with what are some strategic science questions and goals that we want to move forward with in the next 5 years. And we had a defined outcome that we wanted from that 3-day face-to-face, which is a set of recommendations. So again, it was that collaborative problem solving. People came face-to-face. And then in the virtual seminars that we did beforehand, it had a sort of a dual purpose. They saw how the technologies were being used. It was beneficial for them to come and watch the seminars, and it wasn't the gratuitous use of technology. It was actually they're using the technology seamlessly, they're getting information from it, and then after they meet face-to-face, they have a deeper understanding of how to use these technologies to communicate with each other. So by doing that, we sort of started building and strengthening the community. So now onto the technical infrastructure. Oftentimes, I won't read these quotes, I'll just summarize them by saying the big challenges to technology is that they're usually not done very well. So you can have a great technology, but then you implement it in a way that if you have too much paperwork to get an account or too many security issues, people will have workarounds or they won't use the technology at all. Another thing that often happens is you have sort of that centralized approach that I was talking about earlier. People aren't able to actually use, customize, and tweak their technologies. So you might roll a technology out, but you make it almost unusable to your end users because they can't do what they need to do with the technology. So what we really try to do is offer a suite of tools. So instead of saying one size fits all, you will use this, we either offer a suite of tools or we stay very up to date on what technologies are out there. There's a lot of free stuff. We use Google Docs. The universities use pretty much whatever they want. So knowing what's out there, knowing what's good at doing what, and offering a lot of things for people to choose from is important. And standards-based, if you make something standards-based, then people can use a lot of different clients to interact with each other because the standards are similar. We integrate multiple technologies for better solutions. The setup that you see here, we're using video conferencing, we're linking it with teleconferencing, we're then taking that feed and putting it into Adobe Connect. So we try to allow people to interact and access each other from wherever they are. Whether it's a fancy room-based system or from a laptop or a mobile device. Simple and transparent as much as we can. That's not always easy in a world of changing technologies, but we try to make it as close to one click as possible. Empowering the end user, really providing solutions where the end user can do things themselves and they don't have to go through us. So we give people accounts and teach them how to use the various things. And then providing experience recommendations and advice. Oftentimes people will come to us and say, oh, I need to do this or I want to use this. And a few questions later you realize that might not be the right solution for you. And we've tried this and we know it doesn't work well in this scenario, but it does work well in this scenario. So we have sort of Mike and myself and Marco and a few other people. We're very integrated with our communities, and people come to us saying, what's the best thing to use, or what's the best couple of solutions to use to communicate and do what I need to do. So as I said, we tap into a lot of different tools and technologies, and we tap into the graduate students to know sort of what's the up and coming and how are they working. We take advantage of Facebook, Google Apps, and then a lot of the things that you've seen here today. And again, giving advice on what's the best technology to use when. As I said earlier, when you're forming, this is a flow chart, and I can point you to the publication that this came from. This is a RAND publication where they looked through all the research that had been done in computer-mediated communication and have this flow chart of what's the best tool to use in what case, what are the pros and cons, and how to mitigate the cons. But basically, forming a new team, you really want face-to-face if you can. Just status, that type of thing. You can do you can do telecons or even websites. But if you're doing something like solving a conflict, you definitely want face-to-face. So choosing the right technology for the purpose that you're working on is important. We do a lot of that. We have an IT working group. It's made up of technical enthusiasts from around the community, and that helps us get information out to our members of how to use the technologies. We test the technologies with them, and it provides us really good feedback to understand how our tools are being used or are not being used. And I think that's really important. Oftentimes you don't get the feedback loop. The people that are developing technologies don't necessarily get high quality feedback as to how it's working. And in the interest of time, I won't go into a lot of detail, but I'll just say we take advantage of the centrally hosted things that we do. Typically our websites, we have extensive databases on the back end for our website. We have a newsletter that goes out to thousands of people, and again, that's more of a many-to-many communication. So instead of us writing a newsletter and sending it out to everyone, people from the community contribute articles, something that they want to let the community know about. They'll either send it to us or they can upload it themselves. We do write articles as well, but we really want it to be a many-to-many, so the whole community contributes, and then we send it out to the entire community. We have an annual report. We've been collecting information about the research since we started. This is something that was started in the past year. It's initiated again by the graduate students, the Social Action for Grassroots Astrobiology, SAGAN. It's an online community, but it's also a very strong in-person community because the graduate students are so enthusiastic about this. They had this idea they wanted to do more mentoring for undergrads and for themselves because astrobiology is sort of an emerging field. So they set up this online community. They have video chats, they do book clubs, they do lectures, but what really drove it was they wanted a mentoring program and they wanted to do it virtually using just their laptops. So they set up this here, and they also can do collaborative editing, work on documents together. This is a screenshot from one of their video chats. These are sort of the organizers. And then, as I mentioned, we do a lot of video conferencing. We have a a video conferencing unit that allows us to connect up to 30 HD video conference sites. We integrate that with Adobe Connect, which you've seen a lot of this week, so I won't go into that. And then we combine all these to do virtual meetings, workshops, journal clubs. Basically, people use it in ways that we don't even think about until they come to us and say, I want to do this event, can we? And we say, yeah, we probably could. So we do a lot of virtual meetings. Both the teams use it. We do the larger scale virtual conferences and education outreach events as well. So we'll broadcast something from a museum using this infrastructure that we've set up. One thing that came out of a lot of this interactions, especially with the conferences, because students were coming into astrobiology from their discipline and thinking, oh, I don't really understand all these other disciplines, or what are the big questions. So the students actually said, we need to do a primer, and that would allow a new astrobiology person to go to an astrobiology conference or a conference outside of their usual field and understand a little bit more about the backgrounds from the other disciplines and what are the big questions that are being addressed. So the graduate students got together and did the first astrobiology primer. The second one is about to come out because they've updated it. But this is something that oftentimes they say they take on the plane with them when they're going to a conference, or they read it before one of our virtual conferences. An interesting thing was this entire primer was done virtually using, it wasn't Google Docs at the time, but using sort of a precursor to Google Docs. So they divvied up the areas, they decided on what sections they needed to write, what would be useful to them, they developed the primer. And it was another one of those rewarding things to see. And we've now started doing large-scale science workshops where no one has to travel. And there's a publication about how we did that. I won't go into a lot of detail, but I have one publication and can point you to the web link if you wanted to download it. It was published in Public Library of Science. But multi-day conferences similar to this. Presenters from all over the world that don't have to travel, and we really try to schedule it so there's a lot of discussion. That's the publication. And now I'll turn it over to Arsev, who will talk about Data 1, and hopefully we will have enough time for questions at the end.
Well, if you have questions during my presentation, jump in. I don't follow a script, so it's more organic. This one you might find this one relevant to your work because this is Data Observation Network for Earth. It's a collaboration funded by NSF to provide a cyber infrastructure for open, robust, secure Earth science data. So the institutions you see all over the world contribute to that, but even a citizen scientist could contribute to the data, or to the cyber infrastructure, or to the data sets they have. The problem is with big data and big data challenges, we do not have data. Most of the time data is in your spreadsheet. You buy a new computer and that's gone. Or you die and that's gone. And actually that's your tax money. I mean, you're paying your taxes. You fund these research. That's your data. 5 years later, someone else comes and again takes your money to collect the same data because you didn't preserve it. So Data One wants to create this huge cyber infrastructure to preserve data. And especially if this is for you, to how to discover data they need to solve research problems. They want to help researchers to help. And third goal of theirs is to provide useful tools to researchers to make sense of that data. How to visualize data, how to interpret that data, how to come up with the right metadata or convert the metadata of these different spreadsheets. They created a script software called DataUp. It automatically scans spreadsheets and converts metadata into one single standard. It's up and running now, by the way. I will show the website. It's interdisciplinary research collaboration. I studied their emergence in my dissertation. It's quite successful. NSF funded 2 projects. The other one is data conservancy. It's about astronomy. This one is the poster boy. They just released a video interview with the NSF program director and Data One's PI. It's online on the website. You might see that. So it's interdisciplinary. How? There are 3 big chunks in the project. One is the computer science geek, what I call the geek boys and girls, of course. But mostly male-dominated discipline, that is, unfortunately, because a female's perspective is needed. I strongly believe that. The second part is library and information science people, and they are the connection between community and the geek people, and also the content providers, so the earth science. So these 3 big families actually merged in this project. As you can see, there are the structures of research working group structure here. This part is the geeky part. This part is the social part. Federated security, data preservation, distributed storage, scientific workflow. These are the areas that working groups focus on. The other part, community engagement, long-term sustainability, education, and also sociocultural barriers to data sharing research group. That research group functions like a think tank in that organization. They just produce thoughts and ideas and studies. They don't, for instance, they don't come up with a new software. They don't do surveys. They are a think tank. It's very innovative, I believe. And 2 groups, usability and assessment and scientific exploration and visualization and analysis, they are cross-cutting and they make the connection between these 2 different groups. And they play a key role, which I will tell in a minute. But usability and assessment group also goes to the people, to the researcher, and they do baseline studies. For instance, we did a survey with 1,300 people all over the world. They're all scientists, and we asked them, how do you take care of your data? Do you take care of your data? Putting it on a spreadsheet is not taking care of it. Do you put it on a server, on a website? Do you share it? Do you preserve it? What kind of metadata you use? It's also, again, on PLOS ONE. We publish it in PLOS ONE at Open Journal, so you could access. I could give you the link. So we went to librarians, and then we went to data people in agencies, federal agencies, and asked them, what do you do? How do you do? What kind of resources do you need? So we brought this information to the geek people so that they could design what community needs. Because most of the time, and Estelle can say, his experiences in this area was, there are a lot of tools that is introduced to community but never take off because people don't like it or something's missing. They don't consider something always. So Data One wants to talk to everyone and get input from everyone. The problem is orphan data, yeah. And the membership structure is flexible. So one people could be in more than one working group. Of course, they always have prime, but I will get into details of that. So why it is successful? First, the team composition. And this is true for most of the collaborations. In a collaboration, of course, you need highly skilled people. And that's given. They have to do very complex analysis stuff. But they also have to be good communicators. If they're not good team players, if they're saying always me, I, yeah, just say I, and run away. And these folks, while they were establishing their core team, went to people who have a good reputation of being a team player, who have a good reputation in terms of using analog and digital collaboration tools. So you might be a very good communicator, but if you're not using Skype, it's hard for you to reach if you live in Alaska. And they have, for instance, someone who lives in Alaska. So you have to be, the members are comfortable. The team composition is diverse, highly skilled, good communicators. There are also some, what I call, bridging members or bilingual members who can speak 2 disciplines or 3 disciplines. That is quite important. I was doing a study, for instance, on data sharing, and I was asking people, how do you preserve your data? And they told me, we preserve it in big refrigerators. And I thought that, okay, I guess they have a huge computer, it's overheating, and I was doing that research in another language, so I thought maybe this is a translation error. Actually, the data I was asking is ones and zeros, and the response was about fish tissues. Of course, they have to keep it in the refrigerator. Fish will rotten. And they have to preserve it because they were doing this research on toxicity in water and stuff. So, a very basic problem, and the whole research could gone to hell. So bilingual people, or people who can talk more than one discipline, is really important. In this case, they had a huge divide during around the first year. The clash, geek people and social scientists. And actually these bilingual people, they worked as emissaries, diplomats, intermediaries, and made peace. So they are important. The second thing to me why it is important is leadership. A leader, especially in scientific collaborations, is not the one who tells you to do something. A leader is who creates the environment for you to do something, because you are already highly skilled, very good communicators, who wants to do research. The leader has to provide you the environment so that you can operate and come up with your own solutions to the problem, because that is your expertise. The leader has to provide you the environment, and sometimes you might steer away, and of course, he or she will remind you that you have a deadline to NSF, but most of the time, his responsibility should be creating that environment for you. Organization structure in Data One was very flexible. It was not only just working groups, that's the current, that was the current slide, but they also did some workshops on certain problems. For instance, federated data. The federated data working group didn't know how to tackle that problem. They had some things they couldn't solve. So everybody came around that problem and they had a workshop. And they did it for other problems as well. So it's quite flexible. Depending on the needs of the collaboration, they come up with a solution. The environment, of course, quite important. It was the right time to have such a NSF solicitation, the fourth paradigm, big data era, when you cannot do this project 20 years ago. And 20 years later from today probably would be too late. So you have to consider the sociocultural, technological, political, scientific environment you have to operate in. And co-evolution, I will come to that in the next slide. And these are examples that I give interesting titles that happened. Well, why a traditional, if Data One were actually Data One is not a traditional collaboration, of course, you know that, but it is not only fully virtual, it's a hybrid, best of the both worlds. And actually, unless you're working on some open source software code creating, most of the scientific collaborations are hybrid. You have a couple of big locations where most of the people reside in. In this one, for instance, the leadership team, half of the leadership team lives in 3 different institutions, works in 3 different institutions. So these are kind of the centers, but the rest of the leadership is all over the place, so it's a hybrid structure. And why I said that at the beginning, the problems are so big, you cannot have all of the resources in one place. You cannot have all of the people, all of the laboratory, all of the super fast computers in one place. So you have to be distributed. The second problem, know all versus power of the masses. This is again, the leadership, the leader's vision. He was a very great team builder. And they always assume that we do not know all. We have to ask people, we have to ask experts, we have to make use of this thing. I mean, most of the time, if you have really grumpy advisors, you know what I mean? Some people, no, you have to do this research the way I want it. I'm giving you the funds. I want you to investigate that thing. The other thing might bring you Nobel in 10 years. No, I want you to. No, it's not the power of the masses. It is quite important. And also, with that, you could utilize community's real knowledge. Especially this project, and they're working on, for instance, on climate change or bird migration. You have the collaboration has a huge citizen science component. So you have to go to the community. Also, you have to go to community because you're training next generation of researchers. So you have to teach them how to take care of their data. Because if you're 45 and you haven't learned it, it's hard. But at the school, if you took a class 1 or 2, and now you know how to take care of your data for everyone, it's quite efficient. So you have to go to students and teachers, and actually library information science part of the project takes care of that. Geeks versus social scientists, that's the problem I mentioned in the previous slide. Geeks wanted to use a software called Subversion to take care of all the document that has been created. It's quite useful if you're writing codes. Social scientists, on the other hand, have no idea of what Subversion was at the moment. And they tried to learn it. And one said that no way we're going to use that. Everybody says, forget it, we're not going to do it. Of course, we said it nicely. But it wasn't, I guess, nice enough because someone from the geek part told me that they had not seen the light. This is the future. They couldn't solve it. It's ironic to to see a collaboration who comes into play to solve data preservation problem and cannot take care of the things in their own house internally. But at the end, through these bilingual members, both parties compromised. They created a digital repository that could serve both of the parties' needs, accessible, easy for social scientists, and robust and efficient for the computer scientist people, and they solved it. The funding environment, for instance, again, in a traditional structured hierarchical collaboration would be a problem because this project started during the 2008 recession, and the whole funding went up down. Everything has changed, but they were flexible enough, adaptive enough. In my presentation, I argue that it's a complex adaptive network, it's a complex adaptive system, so they could overcome these problems. Also, there are a lot of, in a long-term project, a lot of things happen. People die, people move, big partners leave, earthquakes happen. So in order to, again, overcome these challenges, you have to be very adaptive. Any questions?
I have a question. These collaborations, you gave an example of these meteor shower and asking people to go and find things. To me, there's really good examples of how you can bring people together. But how do you actually build a sustained, effort, over multiple years?
Well, money first.
Okay.
Without Jews,
Yeah.
it can't happen first. Then, actually, that's Estelle's experience. That part is building a community that is sustainable. Because no matter what you do, if you're not considering the environment you operate, it cannot be sustainable. For instance, superconducting supercollider project. $4 billion just wasted on that. And the project couldn't be completed. That part, they shoot some movies there now. A chemical company bought the facility. They spent $4 billion in 1990s. It's an adjusted inflation because they didn't consider, for instance, the reaction from the physicist community, reaction from the scientific community, or the American financial situation, record deficit, or there were no Red Russia to show off. The world has changed. The paradigm shifted to a more international collaboration and understanding. So you have to first take into consideration in what world you operate. The context is quite important. And then you have to take care of it. Actually, the system kind of takes care of it because...
But the context is also changing, though.
Of course.
Yeah.
Of course. That's why you have to be aware of that, and that's why it has to be a complex adaptive system, and that can only be achieved through a bottom-up formation and the right leadership skills.
In the case of NAI, I can see why it can be successful because it's a brand new discipline.
Right.
And right from day one, it was declared as a virtual institute. And so the turf wars are a little different, in those cases.
They weren't trying to switch something over.
Yeah.
Yeah.
But in a traditional discipline like ours, where people have been doing this for decades, what kind of incentives that you need to provide to sustain this over time?
My advice would be to identify the attractors in the field and establish things that could be institutions, research programs, or workshops around these attractors. For instance, for data one, there were two attractors. One of them was NSF solicitation, of course, money. And the second one is the severity of the problem they want to tackle, that was climate change. People felt responsible, and they thought that, I have a degree in atmospheric science, I need to use it because this problem is important. I don't want my child to suffer 50 years from today because I didn't take action. So you need to identify these attractors and support activities around these attractors. And if they reach critical point, they will become stable. But that's, complexity theory and nothing really about that.
A question for international collaboration. What are the sort of main issues you run into when you're trying to get, data sharing across borders or?
For data, it hasn't been a problem, but do you want me to repeat the question? With any government agency, there can't be transfer of funding to a foreign partner, and so it's really figuring out the motivator, what's the benefit to both sides. So oftentimes, a researcher in another country can say they're through partnering with us, then they're more able to get funded through their mechanisms in their country. So, astrobiology, it's very academic, very open. We would run into very different challenges if we were doing pharmaceuticals. And that's one thing I think as we see more of this forming in disciplines or areas where things are more proprietary, we probably will have different issues that we run into. And again, that's the understanding the culture of the area that you're working in, and that's why having social scientists that can bring in all these components and help you predict what is coming is very important, because I think you touched on this funding. There's continuity in building your community and bringing in graduate students and establishing your social network or your research network. But bottom line, if there's no funding, there's only so much.
Probably, really important
Trust is a huge one. Yeah, yeah.
Because everybody in the end is competing for money.
Right,
They
right.
may be doing things for the good of the world, but
Yeah.
in the end, they have to take care of themselves somehow.
Right. Bottom line, that's the driver. Yeah.
Well, in terms of getting credit for data, collecting data or sharing data, if it were possible to get credit for that, that might, according to our survey, that might help to change some of the attitudes. Because in order to get your tenure, you have to publish articles,
Yeah.
not data. But actually collecting that data is a huge work, and it should be rewarded somehow.
Mm-hmm.
So people said that, fair exchange of data, we provide them with certain conditions, and one of them was that getting acknowledged by their department for their
Yeah.
motivation, that would be more.
Yeah, social capital is a strong one,
Yeah.
and there's been some interesting discussions lately on, everything is focused on publishing. Your success is sort of measured by your publications, but now there's interest in data sharing and how valuable your data is, and so that might be a paradigm shift that we start to see of, I have this many publications, but I've contributed this much data.
For instance, data one, I'm sorry.
No, I had a different question. Why you continue?
Providing a training on how to cite data.
Mm-hmm.
Because you know how to cite an article, but many people do not know how to cite a data set. So, but if you knew, probably you would. I mean, you're not a jerk, you would. So these kind of basic stuff, especially with the early career scholars, in the long run could help in this program shift.
I was wondering how decision-making is done in these collaborative groups.
Mm-hmm.
Is it consensus-based? Do they vote? And is there somebody coordinating that?
Yeah.
I would imagine like a whole bunch of ideas are thrown out.
Yep.
How do you come to a decision?
That's a very good question, and I can say there isn't any one way. And we're a formal institute that has funding, and so there's someone who's sort of the person in charge. They're going to have an easier time making a decision than more of a loose collaboration, which I think we see that in science all the time. But as far as decision making, I often see the leaders in the community. I've been in a lot of meetings, and there's one thing that I've noticed is they rarely go to vote. They are very good in discussing and either directing it towards a decision that the leader thinks is a good outcome, or hearing input, making people feel heard, and then saying, here's my decision and this is why. And the leaders often have the respect of the community, and so the community members will go along with that, even if it wasn't necessarily the outcome that they thought was the best. But the thing that I've noticed time and time again is it's usually through consensus building, and it's not through a vote. And there's something powerful in that when we're working in this new global world, in that building consensus, making people feel heard, and making a strong decision, but not saying, okay, 49 people said this, 51 people said this, therefore we're going this direction. Then you're not going to get a lot of ownership. So it's interesting. But again, as I said, there's sort of the loose collaborations where people are working together because it's valuable, and then there's when you're the director and you're the funding source, you can make a stronger decision. So it's going to change depending on the organization that you're in.
That's good. I'm university-based. I'm right now studying the 14 teams of NAI. I study each one. And, teams that are based at universities are different than teams based in federal agencies. Federal agencies have more, probably, that bureaucracy culture. So I'm using the strong leadership, not in the sense of, maybe it's not the right term, but they are more involved in most of the decisions. In academy-based teams, it's more relaxed or more...
It's more distributed. It's PI getting
Yeah.
funding and working autonomously, or it's more agency leadership structure.
You see the hierarchy clearly.
And you definitely see people tapping into the experts to get input, and then making sure that they're informing the people that they need to inform up the chain of command. so they're not hitting someone with a decision by surprise.
I have a quick question about, in your slide that had all of the many of the tools that you're using, I was wondering about tools for getting people to meet at a certain time, coordinating schedules essentially.
Like, what's the one that we've been
Doodle?
using? Doodle, yeah.
Yeah.
Doodle is the one that lately everyone is using and finding it very successful.
Yeah.
So, and again, that's, we don't really have any one tool, but just knowing all the different things that are out there and saying, oh, try this. Doodle has been the best. And then there's the NASA calendaring system, which works well if everyone's on the NASA system. And that's one of the challenges in these hybrid organizations that we run into is that, I'm trying to schedule a meeting with 10 people and 3 of them are at NASA, the other folks are at universities, so I can't see their schedules. So again, that's, having these cross academic government agencies, even businesses, you don't have the luxury of one enterprise solution. But yeah, Doodle's a good one.
Yeah, been using Doodle a lot.
Yeah. And like that slide that we showed, the technologies are changing so quickly. That's why I think the IT working group works well, because we try different things out, we share things, and people come to us. Our community feels very comfortable coming to us saying, what do you think about this? Or we'll test things out. And Mike and those guys are always trying out new, innovative ways of doing things.
Well, with that, we probably should close. And Estelle and
Thank you.
Arsev are available.